Good morning to all of you. In the yesterday, we have covered some part of the reactions of pyridine and oxides. In that, we have covered some reactions, that is the chlorination reactions of the pyridine and oxides. And the reagent used for these reactions is the thionyl chloride SOCl2 along with the POCl3. Next reactions we have covered in the last lecture is the bromination reactions. Bromination reactions, the starting material is the pyridine N oxides, and on the arrow the reaction condition means that we are provided the reagent Br2 and along with the temperature conditions. So we will get the two products, that is the product at the three positions, we get the only one product, the product at the three position, that is 3 bromopyridine N oxides, and then we reduce this oxygen atom by using the zinc dust. So we will get the nitrogen containing ring means n bromopyridine rings. So next reactions we have covered in the yesterday lecture is the nitration reactions. In the nitration reactions we are taken the starting material as the pyridine N oxides. So we have done the nitration of the pyridine N oxides. On the arrow we have used the nitrating agents, and well-known nitrating agent is the concentrated S2SO4 along with the concentrated HNO3. So the nitration takes place at the para position, that is 4 nitropyridine N oxides positions. This is all about the nitrations. Nitrating reagent is the most important. Sometimes questions, MCQ questions also ask on the pyridine and oxides or ask on the nitrating agents, so it is an important part. Next one is the amynations, not amylation. It is here is the word written the amylation. It is amynations. Amynation means the addition of amine groups. So in the amynation reactions, the reacting material, starting material is the pyridine N oxides, and the reagent or reaction condition provided for the reactions is written on the arrow, and this reaction condition is the liquid NS3 along with the NaNH2 sodium nitrite. So this gives the nitration reactions, and the product forms at the two positions and the three positions. The one reacting material is the 2 amino pyridine N oxides, and another one is the 3 amino pyridine N oxides. Next one is the pyridine N oxides reactions, and there is a formations of the addition of the carboxylic groups at the one positions. So two positions, at the two positions the addition of COH group, so it is directly cannot attach at the two positions COH group. So firstly we have to make the carbon atoms as the nucleophilics, and then will take place the electrophilic substitution reactions. So for that we are use the reagent, that is N-butyl lithium as the strong base, which is a very strong base to abstract the protons from the second positions, abstract the formation of carbon anions, and that the metal lithiums attach and form the lithium complex of the pyridine N oxides, lithium salt of the pyridine N oxide, which is on reaction with the CO2 carbon dioxide along with the hydrogen gas, we will give the carboxylic acid at the products. So this is the part now we have covered in the earlier lecture. This is the most important parts. One important key to understand this is the practice, and confusions, it may be chances of the confusions that pyridine N oxide, quinoline and isoquinoline may be mixed, so it will be covered only on the basis of the practice. If you do the practice of this part, and then you can cover all these things. Next is the reactions of the quinolines. So quinolines reactions, now this is also the halogenation reactions, nitration reactions, amylation reactions, reaction with N-butyl lithiums, and reaction with reducing agents. So we know that the The halogenation reactions, how it is done. The halogenation means the addition of the halogen groups on the quinolines. So halogen groups include the chlorine. First is the fluorine, chlorine, bromine, and iodines. So generally, the maximum reactions bromine, chlorine, and iodine are used, and fluorine is not compatible and not used usually in maximum reactions because it is not um, favorable to all the reactions. It is selectively used only very few reactions. So halogenations, we are here done the bromination reactions. So for the bromination reaction we are used the reagent that is Br2. So the starting materials of this reaction is the quinolines, and first is at the first position there is a Br2 and concentrated S2SO4 along with the temperature that is 75 degrees centigrade temperatures. So concentrated S2SO4 is acidic mediums helpful for the addition of the bromines. So brominations takes place at the favorable positions. We have studied the part at that where we studied that the quinoline shows the electrophilic substitution reactions at the 5 and 8 positions. We have drawn the various structures also resonating structures of the 5th positions and the resonating structure of the 8 positions. So we understand that the quinoline gives the maximum reactions and very stable reactions at the position 5 and the position 8. So the quinolines are after the brominations along with the concentrated S2SO4 at the 75 degrees centigrades gives the bromination at the position number 5th and the bromination at the position number 8. So we get the two products. Next is the nitration reactions. So in the nitration reactions, we use the quinoline. So in the quinolines, along with the concentrated S2SO4 at the 0 degrees centigrades. For the nitrations, we use the nitrating agent that is the which is the nitrating agents that is the concentrated H2SO4 along with the concentrated HNO3 is the well known nitrating agents. So nitration is also takes place at the position number 5 and the position number 8. So we will get the product of 5 nitroquinolines and another is the 8 nitroquinoline as a two products of these reactions. Next reactions is the amylation reactions. So in case of the amylation reactions, the starting material is the quinolines, and on the arrow there is the right here. This is the quinoline attached with the nitrogen atoms. Oh, and along with the nitrogen, this is NaNH2, NH3, and the KMNO4. So these are the materials we are using in these reactions. So that is NaNH2, sodium nitride, NH3 is amine, and KMNO4 is oxidizing agent, and along with the some temperature part used. So you will get the amination. So whenever you are doing the amination reactions, to always first thing will come in your mind that the reagent will be NaNH2 and the NH3. As we know that the nitrating agent is the HNO3 H2SO4. Same thing is with the aminations also. Maximum cases we use the NaNH2 along with the NH3 as the reacting starting materials for the reactions. So this is all about the reactions. So we will get the products. First product of the reaction is the product of the reaction is the product of the reaction is the NH2 at the position number 2. Amylation takes place at the position number 2. It is possible because at the position 2 NH2 is the more stable, that's why the position number 2. Then further steps is also one further step takes place, that is the arrow is written here. Next step, and the NaNH2 NH3 means the again again understand that the 4 amino chlorine also formed, means that we will get the two products. Means the temperature difference, we understand that the the two reaction part is the starting material. You know that the starting materials of the reaction is the pyridine oxides along with these reagents. So pyridine has the starting material is the quinolines. So quinolines reactions are taking place by providing the two different conditions. In the first condition, only difference in the temperature cases. In the first, that is the first cases, at the minus 66 degrees centigrade, product means all reagents are the same. So all reagents means NaNH2 is the same, then NH3 is the same, then KMNO4 is the same. This part is the same for all the reaction, all the two reactions, two arrows for all these two arrows. But only one difference is here, that we are providing the different temperatures. So for in the first case we are providing the minus 66 degrees centigrade. In the first case minus 66 degree centigrade, and in the second case we are provided minus 40 degree centigrade, minus 40 degree centigrade. It is done only in the case of amylation reactions. So we will get the two products, two different products. In the case when the temperature is a minus 66 degrees centigrade, at that time we will product form at the two position with the reactions. At the two position is the NH2. At the two position is the NH2, and in case of the second reaction, that is at the minus 40 degrees centigrade. So second reacting material is the second starting material is the NH2 at the position number 4. So we will get the two product at the position number 2 and the product at the position number 4. So this 2 is the most important for the chemical reactions of the, that is amylation reactions of the quinolines. So this is two most important part we have to remind. The difference only in the temperature condition, one is the minus 66 degrees centigrade and another is the minus 40 degree centigrade. These two temperatures are there. Next one is the another part. Next one is the another part, that is the reaction with the N-butyl lithium. So N-butyl lithium is the strong base. N-butyl lithium is a very strong base. So this N-butyl lithium react with the quinolines and form the lithium salt of these quinolines. So that at the position first, there is the formation of the butyl at the position first. So the reactions we can write in this way. We are doing it the N-butyl lithium along with the room temperature. So we will get the product at the position number 2, that is butyl groups. So this is all reactions, and then the next step is the S2O added there. S2O also get added and form the two butyl quinolines. 2-butyl-quinoline is the materials of the product. Next reaction is the reaction with the reducing agents. Reducing agent is the what? The reductions and oxidations are the two concepts. In case of the electron, in case of the oxygen, in case of the hydrogens. So if there is increase in the hydrogens means it is a reduction. In case of reduction, reducing the oxygen means reduction. In case of increasing the electron, also reductions. In opposite contrast, if the oxygen increases means it is oxygen, hydrogen reduces means oxygen, electron reduces means it is the oxidation. So this in these three cases we can study that. So if reductions takes place, reduction means the removal of the bonds and formation of their hydrogen atoms. Means hydrogen increases, so it is also increasing the hydrogen means it is also reductions types of the reactions. So this is the 1 2 3 4 tetrahydroxyquinoline is the reaction materials of these reactions. We will get the products and the 1 2 3 4 tetrahydroquinoline as a product of this reactions. So quinoline converted into the product. The reducing agents is the S2 PTCS3OH, S2 PTCS3OH, S2 PTCS3OH is the reacting materials given on the arrow. So we will friends, this is all about the reactions of the halogens. Some reactions are remaining. These reactions we will discuss in the next part. Definitely we will make complete this part in the next lecture. So do the practice of this part. Thank you and thank you very much.